Let us try one. Consider the graph below, starting at the warehouse W. You want to visit houses A, B, C, and D before returning to the warehouse. Find the minimal distance using the nearest neighbor method. All right, we're starting at warehouse W. From warehouse W, we can go to A, B, C, or D. Which one's the closest to warehouse W? D. D is 140. So we're going to travel along this path, and now we're going to end up at D. From D, we can go to A, B, or C. We can't go back to W. From D, which one's closest? C. Not just for cookies. Good. From C, we can go to A or B. We can't go back to W yet. A. Oh, I meant to circle that one. That's okay. From A, where do we have to go? To B. Yeah, because we have to. Is that okay? I don't know why I'm circling the letters, but that's okay. Now from B, where do we have to go? W. Good. So we took the path 140 plus 120 plus 150 plus 90 plus 290 using the nearest neighbor method. I have no idea what this sum is. I got 790. So according to the nearest neighbor method, we should do W, D, C, A, B, W. But the nearest neighbor method is an approximation to the real answer. It may not actually be the best answer. For instance, if we just went around the horn, so the pentagon itself, if you add up all those values, you get 730. So that would have saved us 60 miles. So think about it, that's an hour at least of driving. So the nearest neighbor method is fast, but it's not accurate. So I'm not saying here that 730 is the optimal answer. I was just demonstrating that, hey, I can find an even smaller one, but the nearest neighbor method doesn't always work. And that's what that one is. So unfortunately, because of the nearest neighbor method, we had to take this 290, and that was the largest one. Wah, 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 wah. I wonder what jerk typed that up. It was me.